Hey folks, I'm going to teach you a new method today for factoring, and it's going to be called factoring by grouping. So I'm going to use examples from 10.6 to teach you this. I think that you'll like it. You can still use the method in 10.6 that you've been using, but I think that this method is going to be a go-to method for you. Okay, so here's a problem. This is example 1 from 10.6. And the first thing you do in this method is you take your first coefficient, this 2 and the 5, and you multiply them together. So we get 10. And now we're going to find all the factors of 10. You can use my method of not missing anything, by writing down. So we've got 1 and 10, of course, 2 and 5, and then the repeat would be down at 5 and 2. So we're done. And of course, you already know that one. But remember, you're going to use the same process here that you've done when factoring other trinomials. We're going to take this positive 5 for the last term. And because this is positive, we know that both of these will be positive or negative. Okay. When we multiply together to get a positive, we have to have two positives or two negatives. Well, to get this positive 11, I'm going to end up adding up. And they're both going to be positives. And of course, then if we add those two terms, then this becomes 11, this becomes 7. This is the one we want, the 1 and the 10. Okay, so now we multiply the two numbers, the first and the last, we got 10. We found factors of 10. And in this case, we added them together because of this. And we're going to use the 10 and the 1. So now watch what I do, because I'm just going to replace my middle term 11x, and I'm going to write it as 1 plus 1x plus 10x or 10x plus 1x. And it doesn't matter the order in which you do it. It's still going to be the same. So I'm going to write this as 2x squared. And then I'm going to have, I'll just do it the order that I've written it in, 1x plus 10x. And then I'll rewrite the 5. So what stays the same? This is the same, and this is the same. You just bring those down, and all I'm doing is changing 11x, and I'm saying, hey, isn't 11x 1x plus 10x? Okay, so that's where I'm getting that from. And 1x plus 10x is 11x, so I haven't changed the problem at all. But at this point, I'm going to group the first section together and the second section together, and then we're going to factor out common factors from each section. So what can come out of 2x squared plus x? What is a common factor? Well, x comes out of there. So I'm going to take x out, and I am left with what times x gets me 2x squared. Well, that would be 2x. So x times 2x is 2x squared, right? Okay, let me see how to make this angle better. Trying to deal with all the shadows and stuff. Okay. All right. And then what times x gets you 1x? Well, just positive 1. And so if you multiply it back, you should get what you have written right above. And we do. And now I'm going to do the same thing here. But when I do it this time, I definitely want to make sure that I end up with 2x plus 1. So what can come out of 10x and 5? Of course, I can pull a 5 out of those. And I'm going to pull out a 5 and watch what I'm left with. What times 5 gets me 10x? It's going to be 2x. There it is. And what times 5 gets me positive 5? A positive 1. And there it is. I've got a match. I've got 2x plus 1 here and 2x plus 1 here. And now by the distributive property, I can pull those out into one, make them into one factor. And I'm going to pull this down. And this becomes a factor, which is x plus 5. And now this is the second factor, which is 2x plus 1. Okay, so what did I do again? Pull this and this down and put it into its own factor. It turns into a binomial. And then these came down. And this harkens back, really, it goes back to what we did at the beginning of the chapter when we were doing the distributive property, and you were learning how to multiply in those first sections that you're allowed to do that, okay? All right, how do I check this? The same way I keep checking all of these. I'm going to FOIL it. So x times 2x squared is 2x squared. And then my outers would be 1 times x is 1x. 5 times 2x is 10x. And my last would be plus 5. Okay, so indeed, I get this. Look at this. X plus 10x is the 11x. I've got my 5. I've got my 2x squared. This totally checks. We just did it right. Okay. Okay, our second example is 3x squared minus 4x minus 7. Again, it's a trinomial. I'm going to factor it, and I've got a leading coefficient, and of course, that last one. So what I'm going to do is take these two numbers and multiply them, and we get 21. 3 times 7 is 21. I also have a negative sign here for that 7. So that's going to tell us something about the factors that I take to find 21. So I know that 1 times 21 could be a factor. And the only other factors we know would be 3 times 7. And we know that one of these is going to be positive and one is going to be negative. So which one will it be to get this negative 4x? Because of this, to get a negative, I need one positive, one negative. But the bigger one has to be negative, right? So what if I make the bigger one negative here? Well, if I subtract those, I would get negative 20. That doesn't work, but this one works. If I make the larger one negative here, I get negative 4, and that works. Okay, so this is our factor. So I'm going to replace my middle term here by writing it. I'm not changing anything mathematically. I'm just going to say I've got 3x squared. And then instead of writing negative 4x, I am going to write plus 3x minus 7x. So what is 3x minus 7x? Isn't it the negative 4x? I didn't change anything. I'm getting ready for this process, but I didn't change anything. And now the negative 7 comes straight down as well. So this just replaces this. Okay, and now what I'm going to do is group together my first two terms and my second two terms, and I'm going to factor out anything from these first two that I can. So I see I can factor out a 3. That's nice. I also see I can take an x out of each of those. So we're going to take out a 3x. And what am I left with? What times 3x gets me 3x squared? Times x. And 3x times what gets me 3x? Plus 1. 3x just times 1 gets you itself right there. Okay. Now I go to my second set of terms here, and I'm going to factor something out of the 7. Remember, I want to repeat this. I want this to be a factor. It's going to be x plus 1. So how do I make this into x plus 1? I see I can pull out a 7. So the real question is in your brain, am I going to pull out a negative 7 or am I going to pull out a positive 7? Okay. If I pull out a positive 7, what times 7 will get you negative 7x? It would have to be negative x and then negative 1. So that will not work. So I'm going to pull out a negative 7, and I will get negative 7 times what? Times x. And then negative 7 times what? Times positive 1 will get me that. So now again, I have a matching factor here. And again, by the distributive property that we learned at the beginning of this chapter, I can pull these terms out and I get 3x minus the 7 times x plus 1. Now, all that's left for me to do is to check and make sure this is right. So let's FOIL it. So 3x times x is 3x squared. My outers would be 3x times 1 is 3x. My inners would be negative 7 times x is negative 7x. And what is my last? Negative 7 times positive 1 is negative 7. So now I'll do those middle terms, and I've got 3x minus 7x, and it gets us what? You bet it does. It gets us negative 4x, and that's what we started with. So we're good. This did factor correctly. Okay, next example 3. Example 3, 6x squared minus 19x plus 15. So again, what do I do first? I take this number and I multiply them. So 6 times 15 gets us 90. So that's the factor. That's the number we're going to find factors for. So I can start with my counting numbers 1, 2, 3 and go down. I'd say 1 times 90, 2 times 45, 3 times 30, 4 times, and I could keep going. 4 doesn't go in, but 5 will go in. 5 will go in 18 times. Now I can keep doing this, okay? Now, remember, this is a positive number here. So both of them are positive or negative, but because this is negative, both of these are going to be negative, which means you're going to add them up this time. So this would be negative 91. This, if I added it together, would be negative 47 or negative 33. This is a lot smaller, so I don't really need these first factors. You can see I need to get 19, so I got to get closer to 19. If I add 5 and 18 up, I still get, what do I get with that? 23, negative 23. So I'm still going down further. Let's see what I get. I can do 6. I get 6 times, what is it? 15 will work. But still, I'm adding those up and I'm at, what am I at? 21. 7 doesn't work. 8 works. And I have 8 times, I don't know. And then I've got 9, actually 8. Yeah, that's not going to work. And I got 9. And of course, with 9, I've got 9 times 10. So we get to our easy factor. And what we're going to see is this works because 9 times 10 is 19. So some of you might have already had that in your head, but 9 times the 10 gets, 9 plus the 10 gets us 19. So that's it. So it's going to be a -9 and a -10. So let's set it up. Again, it doesn't matter. I could put the 9 in front of or the 10 in front, right? When I do this step, it doesn't matter. It's going to turn out the same. The first term gets written out as it is. And now I'm going to rewrite this one as -9x, -10x. Then the 15 positive comes down. Isn't -9x, -10x equal to -19? Yes, it is. So I haven't changed anything, just the way it looks. Now I'm going to take my first 2 terms and my last 2. I'm going to factor out what I can. I'm always going to be able to pull out an X of these. Always. A number most of the times, but also I will always pull out an X, okay? So the number won't always come out, but an X will. So I can take a 3 out and I can take an X. So what am I left with? 3x times what? Times 2x right there. 3x times 2x is 6x squared. How about 3x times what gets us this? How about -3? Okay. And now let's pull something out of here. And again, I need to have a match. I'm wanting it to match exactly the 2x minus 3 over here. So what can come out of the 10 and the 15? I can pull a 5 out. Okay. And the question is am I going to pull a 5 out or am I going to pull a -5 out? Okay, so if I pull just a 5 out, how do I get -10? Oops, it would be -2x. So that won't work. So I'm actually going to have to pull out a -5 and watch what happens this time. Now I'll multiply -5 times 2x and watch what I get. Of course, that's -10x. And -5 times what gets you +15? -5 times -3 gets you +15. So negative is positive. And look, it's a match exactly like we wanted. So how do I rewrite the problem from this point? I take this and rewrite it as a binomial multiplied times another. And then I rewrite the second one, which is just going to be the 2x minus the 3. How do we check to make sure our work is correct? We FOIL. So 3x times 2x is what? 6x squared. I've got my outers, which is -3 times +3x, which is -9x. I've got my inners, which is what? 10x. And I've got my last, which is +15. So I've got my 6x squared and my 15 match. But what about the middle terms? What is -9x and -10x? Yep, it's -19x. So this worked. We did it. Okay, good job. For example, number 4, I'm looking at this and I can see that I have a common factor that can come out of all 3 terms before I even start the other process. So I could take a 2 out of all these. So let me do that. So what I'll have then is 2 times 3x squared, 2 times -1x, and 2 times -4. And at this point then I can multiply my 3 and my 4 together and begin the process. Now, what if you didn't see that? And what if you just started factoring it from there and you said 6 times 8? You can do that. And maybe I'll do that next to show us that it will work. It'll be fine. Okay. So let's go ahead and do this. Let's multiply 3 times the 4 and we get 12. Of course, it's a -12. Positive times negative. This is -12 right here. And because of that, I'm going to look at the factors of 12 and I want the middle term to be a -1. So we have a 1 and a 12. Of course, we've got 2 and 6 and we've got 3 and 4. And then I have my repeat of 4 and 3. So I'm done. I know I'm totally done. But let's look at these. Since it's negative, one's positive and one's negative, the larger number has to be negative because of this. So let's just make the larger numbers negative. If I add these together, I get -11. If I add these together, I get -4. And if I add these together, I get -1. So this is the one that works. So let's set it up. I'll leave the 2 out front. And now what I'm going to do is rewrite it the way I did the others. The first term gets written as it is, but my negative 1x is going to be written as this. So I'll write positive 3x minus 4x. And there it is, positive 3 minus 4. And doesn't that equal negative 1x? Yes, it does. Now I'll rewrite that last term, put it back in parentheses because all of this is times 2. I didn't change anything here. This is totally equivalent to this, okay? Now we're going to group them together. So I'm going to group this one and this one together, and let's see what we can pull out. I always am going to be able to pull out an x from this one, and now I can also pull out a 3. So I'm going to change to a bracket so it doesn't look so complicated. I'll pull out a 3 and an x, and what am I left with? 3x times what? Well, just x. And then 3x times what to get 3x? Just positive 1. So now my match on this side should be x plus 1. That's what I'm looking for. So what can I pull out of negative 4x and negative 4 to make it positive x plus 1 over here? To do this, I need to pull out a negative 4. Watch what happens. So negative 4 times what gets you negative 4x? Just x. And then negative 4 times what gets you negative 4 plus 1. So there's my match. And this is the trick right here. You've got to know, do I pull out a negative 4 or a positive 4? That's kind of the deal right there. Okay. Putting this back in the brackets just to clean it up. And this will equal, now I'll rewrite it as 3x minus 4, and this times x plus 1. All of this right here is equivalent to what we started out with. Let's FOIL this and see if we end up with this right here. So 3x times x is 3x squared. Check. My outers would be positive 3x. My inners would be negative 4x. And what is 3x minus 4x? Yes, it's negative 1x, what we started with there. And what is my last? Negative 4 times positive 4 is negative 4. And that also checks. So we're good. If you multiplied the 2 through, you would see that we would have that exact, that trinomial up there, okay? So it is a match. Now, some of you have asked me in the past, what about this 2, Mrs. Harley? What do I do? I can leave it like this right now, but if I multiply it through, does it get multiplied times both of them? No, you just would multiply it times one of them, and we would end up with like 6x minus 8 times this, okay? So let's do this problem again, now assuming that we didn't see that we could pull out a 2 first. And we'll end up with a factoring. It'll look a little bit different at the end. But again, it'll be something like the 6x minus 8 times x plus 1. Or it could be the opposite. It could be 2x plus 2 times the 3x minus 4. All of these 3 answers would be equivalent. So let's take this, do the process again. We're going to multiply 6 times 8, and we're going to get 48. Now I need all the factors of 48, so it's a little higher. 1 times 48, 2 times 24, 3 times 16, etc. And I keep going. Because it's minus, you know one's positive and one's negative, and they end up getting subtracted. Okay, so how do I get a 2? How do I get a 2 in here, negative 2? These numbers have to be pretty tight. They got to be close together in order to subtract and get a 2. Because if I subtract even 16 minus 3, I get 13. I am too high. So you can just keep going down. Oh, of course, I have 4 and 12. And let me just say 5, of course, doesn't work. I'm still doing my counting numbers. But then I've got 6 and 8, right? And look at that. If I subtract those 2, yes, I get a 2. So these are the magic ones. Do you see how this is a little bit easier than the first process, how we learned how to factor on 10.6? It's a little bit less random, okay? So we're going to use the 6 and the 8. Again, I'm going to rewrite this first term as 6x squared. How do I get a negative 2? Well, this one's positive, this one's negative. So I'll write positive 6x minus 8x. Then the negative 8 comes down, okay? This just replaces this, and that is negative 2x, so I'm good. So now this and this, I'm going to factor out what I can. I'm going to take an x and a 6 out. So I've got 6x times what? X and plus 1. So again, here's my x plus 1, similar to what we just did. And now what do I have here? I'm going to take out an 8, but am I taking out an 8 or a negative 8? Well, I want to have x plus 1, so I've got to pull out negative 8, because negative 8 times x equals negative 8x, and negative 8 times plus 1 equals negative 8. So I've got my match, and now this will be, what did we say a minute ago? It'll be 6x minus 8 times the x plus 1, and that's fine. And it's exactly what I told you a second ago. If you were to distribute that just here, that you would get the 6x minus the 8, okay? If I perhaps had reversed this, then put the 8 over here and the 6 over here, maybe it would look a little bit different, and this one would be different, okay? And it's all good, but that's enough for you right now. Good job. All right, so for example 5, I've got an equation this time. I'm not just factoring it. Now I have an equation, so I'm solving. And what am I going to end up solving for? For the zeros. What are we going to find out? We're going to find out when this quadratic equation, when this second degree equation is going to cross the x-axis. It's a parabola. We're finding out where it crosses. But before I do that, I've got to collect like terms. So this has to come over and this has to come over, right? So don't I have to say negative 6n and negative 11? Subtract both of those from both sides? Sure. So what I end up with is 21n squared plus 8n. 14 minus the 6 is 8. 7 minus that is negative 4. And then I'm left with 0 on this side when I subtracted that. So now I'm going to try factoring this. 3 and 7 go into this. 3 and 7 don't go into that. So I can't take out anything here. I can't factor out any factors, common factors. So I'm going to use my method now. I'm going to take 21 and I'm going to multiply it times 4. So what's 21 times 4? 84. And now I want to find all the factors of 84. Well, here I go again. I'm starting with 1 times 84. But do you notice that this is negative? So what does that mean? One of these is positive and one is negative. Also, which one's negative? The smaller number will be, because we want the positive, we want the answer to be positive. So the smaller number will be negative and this would be positive. So it ends up subtracting. So what is negative 1 plus 84? Eesh, 83. That's way off. I want to be at 8. So again, you got to get the numbers closer together. So when they subtract, you get a smaller number. So I could keep going. I could be like 2 times 42. That doesn't matter. When I subtract those, I'm still at 40. I'm way off still. So let me see. 3 times 28, I'm still way off. If I subtract those, I'm at 25. And 4 times 21, I'm still too high. And let's see. 5 doesn't go in, of course, and 6. 6 times what is 84? I need some of you to do this arithmetic for me. Well, 6 times 14 is. 6 times 14 is 84. And when I subtract the 6 from the 14, I get what? 8. Which one's positive? Which one's negative? The 14 is positive and the 6 is negative. Now, again, I don't care which one you put which. In fact, since I've done the 6 on this side, why don't I do the 14 over here so you can just see that? So if I have 21n squared and I say plus 14n minus 6n, and then I have minus 4. So what is 14n minus 6n? Yes, it's equal to 8n. I didn't change anything. This is an equation this time, so it's going to be equal to 0. So let's now find what we can factor out here and then find what we can factor out here. All right. So what comes out of 21 and 14? 7 does. What comes out of n squared and n? N does. So I take out 7n. And what am I left with? 3n plus 2. 7n times 2 is 14n. Now what can I factor out of here? I want to get 3n plus 2. So what do I have to take out to get a 3n plus 2? I've got to take out a negative number. Yes, I have to take out negative 2 will come out. And negative 2 times what gets you negative 6n? Well, 3n. Negative 2 times 3n is negative 6n. Negative 2 times what gets you negative 4? Well, positive 2. Negative 2 times positive 2 is negative 4. And look, it's a match. 3n plus 2, 3n plus 2. I got my match. So I'm good to go with this. Now I'm just going to do my method, which is 7n minus 2. And then I rewrite this factor as 3n plus 2 equals 0. All of these are equal to 0 this time. So I'm going to find the zeros actually. We could FOIL this back and see. Let's just do the outers and inners so you can see. What is 2 times 7? 14. Positive 14 minus 6 is 8. It works. But now we're finding the zeros. So what happens to find a 0? Well, I have to make them equal to 0 so to see what will make this equal 0. So 7n minus 2 equals 0 when what happens? I add 2 to both sides and I get 7n equals 2. Divide both sides by 7 and I get n equals 2/7 is one of the answers that will make this equal to 0. The other answer will be 3n plus 2 equals 0 when 3n equals what? Yes, -2. It becomes negative. Divide both sides by 3 and I get -2/3 is the second answer. Okay. All right, very good. We're almost done. For our last example, we've got another cliff diver here. And so the cliff is going to be 48 feet tall. So that's the jumping height, where you're jumping from, right? We call that the initial height. Where's the initial height in this formula? And you better know this by now, right? The initial height is S, right? That's the starting point. You guys used to tell me that was what? The y-intercept. Of course, if these were zeros, if the t's were 0, the time was 0, what would the y-intercept be? It would be where that person is standing at the beginning of the jump. The shape is a parabola. I'm jumping, and when am I going to hit the ground? I'm going to hit the ground when the ending height, when this height, so this is the height at a certain time. At any time in the jump, you can find the height. 1 second, 2 second, 3 second, whatever. Okay, that's the height you'll find. So this is the initial height. This is the ending height after a certain amount of time. Okay. So now we're also given something else on this one. This person didn't just fall off the cliff. They jumped. So there was an upward motion, and that jump was it was like 8 feet per second or something. There was a velocity to it. Okay. So this goes into the velocity. The initial height is 48. So there's my velocity now, initial height. And what do they want to know? They want to know, when am I going to hit the water? Well, when am I going to hit the water? When h equals 0. So that's our formula. Okay. So let's go for that. And we're going to use the same method we've been using to solve this formula now. We want to know, what is the time when the diver hits the water? Okay. First of all, I'm looking here and I'm like, oh boy, I can take out 2 at least. Not only that, I could take out 4 from all of these, and I can certainly take out 8. So I'm going to divide everything by 8. But in order to keep us happy and make this term here, was it 8? It was 8. In order to keep this term positive, I'm actually going to pull out a -8. Okay, so let's pull out -8 just to keep this first term positive. So -8 times positive 2t squared gets us -16t squared. -8 times what gets us positive 8t? -t. And -8 times what gets you positive 48? -6. Okay, we want to know when this is equal to 0. So now here I go again. I have a leading coefficient and an ending coefficient. I'm going to multiply them together. And I get what? You get -12. So give me factors of -12. And I want to end up with a -1. Of course, I've got 1 and 12, 2 and 6, and 3 and 4. Okay, because this is negative, one's positive and one's negative. Which one's negative? The larger number. So make the larger number negative. And here I go. So I've got a 1 and a -12. That would get me what? -11. That doesn't work. 2 and -6 would get me what? -4. That doesn't work. And 3 and -4 would get me -1. This is the one right there. That works. So let's factor it. 0 equals -8 times. And I will get, let's factor it by grouping. I'm going to replace this with this. I'll have 2t squared, and then I'll have plus 3t minus 4t. That certainly was -1. It just replaces that. And now I rewrite my -6. Here I go. Okay, so now I've got this. Now I've got to factor this. What comes out of 2t squared and 3t? Just t. And I better use a bracket just to not have double parentheses for you. I don't want to get it too confusing. So we'll just pull out a t, and I get 2t plus 3. And now out of this one, I'm going to pull out what? Well, I want it to be positive when I do this, so I think I better just pull out a negative number. I'm going to pull out -2 and see what happens. I get a -2 times what? Just 2t. Oh, that's a match. Nice. And then -2 times what gets me this? +3. Negative times positive is negative. That works. I've got my match, close my bracket, and now I can rewrite it as -8, and then I'll rewrite it as t minus the 2 times my matching binomial. And there it is. All of this together equals this. So now we do want to find this out. When is this equal to 0? Well, either this has to be 0, and that can never be 0 because there's not a variable in there that I can turn into 0. When is this one 0? Yes, when t equals 2. And when is this one 0? Bring the 3 over, so it would be 2t equals -3, and then t equals -3/2. Can I have time that's -3.5 or 3/2 seconds, -1.5 seconds? No. So it only makes sense to deal with this part of the parabola. When t equals 2 seconds, that diver is going to hit the ground, hit the water. How far did that diver jump off that cliff? 48 feet. So at 2 seconds, he's going to hit the water. Okay. Now, we were just practicing our grouping, but it can be applied to all of your problems. Okay, good job. And I'll wrap this up in a second. Okay, let's look at another example. Really, ultimately, I just want you to, we're going to multiply two numbers together, and I want you to remember how to find the prime factorization of something. So if I multiply 56 and 22 together and get 1232, how do I find the prime factorization of that? Well, I already know that 22 goes in and 56 goes in, so I can just start there. I mean, there's no, let's just do that. And then 56, what is that, folks? Okay, 7 times 8. And what is 22? 11 times 2. So now I've got, for 8, what do I have? There's Gabby girl. Got the neighborhood calling system right now while the dogs are barking. So here I'm just going to break it down. So I've got 222 for the 8. And there it is. Come here, Gabby girl. Come on. All right. So I've got all of this equals that. No, so if I'm going to ask you how to find me different combinations of numbers that equal 1232, how can you do it? Well, you could start with something like, I could go in order 1, 2, 3, 4, 5, and do like I've been doing with you, right? In fact, why don't I write this as the prime factorization of just this. Let me just write it in order. So it's 2, 2, 2, 2, which is 16, and then 7 and 11. I'm just putting it all in order. Okay. So I could have 1 times 1232. I could have 2 times what? We'll just take 2 out and multiply all that stuff together. And what do you got? You're going to get 616. Okay. I could take 3 out. There's no 3s in here. 3 doesn't go in. 4, take a 4 out. 2 and 2 is 4. And what's left? 2, 2, 7, 11. And that would be what? 4 would be 308. Does 5 go into this number? No. Does 6 go into this number? No, because there's no 3 in it ever. How about 7? We know 7 goes in. So pull the 7 out. I'm left with this, which is 16 times 11. And 16 times 11, what is that? 176. Okay, you get the idea. Now, I just want you to see how to form combinations of numbers by using prime factorization. You don't have to sit there and divide over and over and over on your calculator or things, okay? Sometimes we want combinations to be a little bit tighter. So let me give you this problem. I'm going to write the problem up here, and I'll start the problem, which is going to have these two numbers in it, and you'll see what I'm doing. So here's the problem we're working on. I think it's number 57. Let me check that. It's 57 on page 615, okay, from 10.6. So what if I have something crazy like this times this, and I get 1232, and somehow you're supposed to find a 61 in the middle? So I start writing all those factors of 1232, and these are way far apart. Because this is subtraction, I know I'm going to subtract to get the middle term. So this is too far apart. Subtract 2 from that, I get 614. Subtract 4 from that, I get 304. Subtract 7 from that, blah, blah, blah. I mean, it just keeps going. They're just way too far apart. I'm not getting 61 in the middle, but I want it. So my numbers are going to have to get higher. But do I have to keep doing these to get there? Well, maybe you could skip some. I mean, 8, 9, 10, 11, 12. You know, first of all, 8 will go in because I have 2, 2, 2. Okay, but it's going to be too far. 9 won't go in because there's no 3s. 10 won't go in because there's no 5s. 11 goes in because we see it, but it's too far apart. 12 won't go in because of the there's no 3s. So keep going. So I've got, let's see, 13, then 14, 15, 16, 17. 13 won't go in. 14 does because 2 times 7. Okay, what does 14 go in? 14 times 88 is the answer. So 14, 2 times 7, right there. And then what? 2, 2, 2 is 8 times 11 is 88. 15 won't work. 16 goes in because here it is, 1, 2, 3, 4. That's 16 times what? 77. Let's try these. When I subtract these two, what do I get? 88 minus 14. I get 74. Closer. I'm really getting close. What about this one? 77 minus 16. 77 minus 16 is 61. This is the one that will work. Okay, so using prime factorization, you can make this factoring by grouping a lot easier. And it certainly took us less time to do this than the original way of learning the 10.6 method. Okay, this is the one. So we'll use 16 and 77, and let's do it. Okay, now we're going to factor this. So I'll get rid of this, and we're just going to do this problem. Okay, and it was 16 and 17, 7. Okay, so I've got 56 W squared, and let's see, 77 will be negative. So how about negative 77W plus 16W, and that will get us our 61, okay? And then we have minus 22. It equals 0, so we're solving for zeros this time. Let's factor something out. I can take out a W and I can take out a 7. So 7W, and what do I get? I get 8W minus 11. And that's what it should look like, okay? And now what do I get over here? When I factor something out, I can take what out of those? Just a 2? I guess so. I'm just going to take a 2 out. So let's take 2 out and see what we get. 2 times what gets us the 16W? 18W, of course. 2 times what gets us that? Of course, it's the negative 11. And there it is. I've got my match. So now I've got 7W plus the 2 times what? Times the 8W minus 11 equals 0. So I want to find the 0. So I set this equal to 0. I get 7W plus 2 equals 0. So 7W equals negative 2. So W equals negative 2/7. And then on this one, I get 8W minus 11 equals 0. So that would be 8W equals 11. So W would equal 11/8. And these are the 2 zeros. Now, how else could you do this really? You could plug it back into the quadratic formula. Okay, negative B plus or minus the square root of B squared minus 4AC, all divided by 2A. You can plug it into your calculator and do it. But we're really practicing learning how to factor these and find the zeros that way. You would have gotten these 2 solutions had you used the quadratic formula as well. Okay, good job. That's it. I just wanted to throw one of the hardest problems out there that you guys threw at me in class, and you got this. Let's just do it.